ओके, लेट अस स्टार्ट द लेक्चर। लास्ट लेक्चर में हमने दिखाया था कि अगर एस रिफ्लेक्सिव रिलेशन है देन एस इज सबसेट ऑफ एस स्क्वायर सबसेट ऑफ एस क्यूब, इट्स एन इंक्रीजिंग सीक्वेंस। Okay, yeah, let's define the following relation. Define this relation as infinity, okay, which is equal to union and runs from 1 to infinity Sn, where this Sn is the composition of Sn times, okay, this is n times here. So this the relation S infinity is called the transitive closure of S. The relation S infinity, here S is reflex, okay, this S is ये आपने last lecture में बताया था मैंने आपको, this relation is reflexive. The relation S infinity is called the transitive closure. Transitive closure of S, and why it's called transitive closure, that we'll see in the next lemma. Why this relation S infinity is called the transitive closure. Okay, let's state the theorem, or you can say lemma also. Let's write it as a lemma. Okay. So for every reflexive relation S, for every reflexive relation S, for every reflexive relation S on a set on a set X, on a set X, the relation S infinity, the relation S infinity कि इसका नाम मैं 1 रखूंगा, डिफाइंड बाय 1, जिसको हमने 1 से डिफाइंड बाय 1, डिफाइंड बाय 1 is the smallest transitive relation, is the smallest, it is the smallest transitive relation, transitive relation, it is the smallest transitive relation on X containing S, containing S, it contains S and it is the smallest such, it is एक तो ये reflexive relation है, second it contains S, third it is the smallest such relation. Proof. क्लास टाइम पर प्लीज ज्वाइन कीजिए. Proof. This S is subset of S square, subset of S cube, so on and so forth. So that means clearly, by definition, you can see by definition, this S, it's obviously subset of this. It is subset of union S power n runs from 1 to infinity. इस union में S1 भी आ जाएगा, S1 is equal to S, so this is a subset of the union, and this union is S infinity, okay. So it means that S infinity contains the relation S. एक प्रॉपर्टी हमने इसकी चेक की है कि ये S को कंटेन कर रहा है, ये किसको कर रहा है कंटेन? S को. इसके बाद जो नेक्स्ट प्रॉपर्टी हम चेक करेंगे उसमें हम दिखाएंगे जो S infinity है, it is a transitive relation. तो दो properties आ गई, और finally we will show that it is the smallest such relation. So now we verify that S infinity is transitive. इस पेज को मैं erase करूँ? Okay. Now we verify that S infinity is transitive. Okay, it's transitive. तो transitive के लिए हम क्या करेंगे? Transitive relation on S. Okay, transitive relation on S, on X, sorry, on X. हाँ, रोल नंबर 6 कैसे इसको प्रूव करें? ट्रांजिटिव है. Yes,
we will take 3 elements.
Okay, let, आप बताए, मैं लिखूंगा, ठीक है. Let x y z belongs to X, then
हमें शो करना है सर x y. If x y belongs to S infinity.
Okay, such that x y belongs to S infinity and y z belongs to S infinity. So what's S infinity? It's actually हमें प्रूव करना है x z is in S infinity, है ना? x z S infinity में, x is S infinity related to z. तो सबसे पहले ये तो नोटेशन है S infinity, इसका मतलब क्या है इसको हम देखेंगे, फिर वहां से क्या आ जाएगा वो हम देख लेंगे. So this means x y belongs to union S power n runs from 1 to infinity, and then this y z, it also belongs to S infinity, which is S power n runs from 1 to infinity. So it is in the union. It means that row number 32, x z x y is in the union. इसका मतलब क्या है? यूनियन में है, तो यहां से आप क्या कंक्लूड करोगी? Implies मतलब यूनियन में है, तो यहां से आप क्या कंक्लूड करोगी? इसके बाद नेक्स्ट स्टेप आप क्या लिखोगी? आप सपोज लिखोगे कोई एलिमेंट यूनियन में है, उसके जो नेक्स्ट स्टेप होगा वहां पर आप क्या लिखोगी? इट बिलोंग्स टू एटलीस्ट वन एस एन, है ना? ये यूनियन है ना, एस एन इसका, S1 यूनियन S2 यूनियन S3, ये यूनियन है इन रिलेशंस का. तो जब ये पेयर इस यूनियन में है, सो इट इज इन एटलीस्ट वन सेट, ये किसी न किसी एक में. सो दैट मीन्स देयर एग्जिस्ट्स n and m इसके लिए एग्जिस्ट होगा, सेकेंड यूनियन जो m, सच दैट x y belongs to S power n and y z belongs to S power m. But this you can say okay. So but S power n, so no, don't write this here. Now we apply the property of composition. Okay, composition. X y is in S power n, y z is in S power m, then Yes, Asghar Fayaz. This implies?
Extended belongs to S power N O.
Okay, excellent, good. XL belongs to S power N, composition S power M, and that's equal to S power N plus M. Okay, and which is subset of S power infinity, because S power infinity is the union of all such relations. So that means this xy belongs to S infinity, yz belongs to S infinity, implies that xz also belongs to S infinity. Therefore, S infinity is a transitive relation. Is a transitive relation. It's a transitive relation containing S. It's a transitive relation containing S. अब हमें प्रूव करना है इट इज द स्मॉलेस्ट सच रिलेशन. Now we show that S power infinity is the smallest such relation. Okay, so for this we take any transitive relation containing S. We will show that S power infinity is subset of that relation. So that means the S power infinity is the smallest transitive relation. So let tau be a transitive relation on X such that this tau is subset of S is subset of tau. S is subset of tau. S is subset of tau. We show that S power infinity is also subset of tau. S is a reflex relation, so tau is also a reflex relation because S is contained in tau. X belongs to S for each X. It means that X belongs to tau for each X. So clearly this tau is reflexive. This tau is reflexive. So therefore tau is equal to tau composition tau, क्योंकि ये transitive भी है ना, transitive plus reflexive, it's equal to tau composition tau, so on and so forth. That is tau is equal to tau square is equal to tau 3, so on and so forth. So now we have this thing. This is contained in tau. Okay, this thing. Now S, which is contained in tau, so it implies that S square is contained in tau square, which is equal to tau. S cube contained in tau, composed in tau, contained in tau cube, we can say that's equal to again tau. So therefore we can say S power n is contained in tau for all n greater or equal to 1. For all n greater or equal to 1, S power n, composition of S n times with itself. S power n is subset of tau for each n greater or equal to 1. Okay, so this S power n is subset of tau, which means that union of these S power n's is also subset of tau, because each Sn is subset of tau. So that implies what's the union of S power n? It's S infinity. S infinity is subset of tau. So hence S infinity is the smallest transitive relation on X containing S. Hence S power infinity is the smallest transitive relation on X containing S. So hence S power infinity is the smallest transitive relation, on X containing S. Now next we have a following theorem which is very important.
सर हमने लिखा ना रिफ्लेक्सिव,
ये
फिर वो इक्वल होंगे वहाँ पे कैसे?
कहाँ पर हमने रिफ्लेक्सिव लिखा?
वो टाउ इज रिफ्लेक्सिव,
टाउ इज ट्रांजिटिव, मैंने रिफ्लेक्सिव लिखा वहाँ पर। आप जरा देखिए, टाउ इज ट्रांजिटिव रिलेशन कंटेनिंग एस। आप वो फिर उसको ठीक कीजिए। टाउ इज ए ट्रांजिटिव रिलेशन कंटेनिंग एस। Tau is a transitive relation containing S. Okay. For every relation, for every relation R on a set X, on a set X, we have this, the smallest equivalence containing R. This RE is equal to R union R inverse union the identity. Okay, तो ये जो रिलेशन है R यूनियन R इनवर्स यूनियन आइडेंटिटी रिलेशन, दिस रिलेशन इज रिफ्लेक्सिव एंड सिमेट्रिक है ना, बिकॉज इसमें R भी है और R इनवर्स भी है, तो ये सिमेट्रिक तो है, और इसमें आइडेंटिटी रिलेशन भी, इट इज आल्सो रिफ्लेक्सिव। बट व्हाट इज RE? RE इज एक्चुअली द स्मॉलेस्ट इक्विवेलेंस कंटेनिंग R, सो वी वांट एक्चुअली दिस शुड बी इक्वल टू सम इक्विवेलेंस रिलेशन। सो यहाँ पर सिर्फ एक चीज मिस है, दैट इज ट्रांजिटिव, सो वी टेक पावर इनफिनिटी। And we know that any relation which is reflexive, जो भी relation होगी जो reflexive होगी उसका जब हम power infinity करेंगे, ये जो relation है ये transitive बन जाती है, और ये relation यहाँ पर reflexive है because it contains Ix. हम prove करेंगे this relation. What's the by definition? What's RE? RE is the smallest equivalence containing R. It is the smallest equivalence relation containing R by definition. So we show that this relation is the smallest equivalence containing R. This one, R union R inverse union identity relation X power infinity. हम प्रूव करेंगे ये जो relation है ये है smallest equivalence containing R. अगर हमने ये प्रूव किया, it means that it's equal to RE because by definition RE is the smallest one. वही तो RE की definition है। अगर हम प्रूव करेंगे इसको, ये वाली स्मॉलेस्ट है R यूनियन R इनवर्स यूनियन आइडेंटिटी रिलेशन ऑन X पावर इनफिनिटी। सो लेट्स ट्राई टू प्रूव दिस रिलेशन इज एक्चुअली स्मॉलेस्ट इक्विवेलेंस। प्रूव। So let's denote this relation by E. Let E be this relation. R union R inverse union IX. So it's trivial that this relation is reflexive because it contains Ix. It's also symmetric because it's R union R in. Whenever X, Y is in this union, then X, Y is in either R or R inverse, or they are equal. They are in identity relation. So if X, Y is in R, then Y, X is in R inverse, which implies that Y, X is also in the union because this union contains R inverse. So whenever X, Y is in this union, then Y, X is also in the union. So that means this relation E is reflexive and symmetric. Then Then this R, it's contained in E, because E contains is a union of four relations, so therefore R is subset of E, and E is reflexive and symmetric. Also by Abel lemma, is power it's power infinity here. Okay, this is this power infinity. Also by Abel lemma, E is transitive. Is okay, this is आप ये मत लिखिए यहाँ पर दिस, देन आप सिर्फ ये लिखिए इसमें E is reflex relation. Okay, E is reflex relation, reflexive and symmetric. Okay, so we don't know whether this R is in E or not, because it's power infinity here. Okay, it's power infinity. So also now we apply the also by Abel lemma, E is transitive relation on X, ये transitive relation है X पर, containing what? Because it's actually what's S power infinity? S power infinity is the transitive relation containing S. अब यहाँ पर S की जगह पर क्या है? R union R inverse union IX, containing R union R inverse union 1x, and hence contains R, and hence ये फिर R को भी contain करे, because it contains the union, and hence contains R. Okay, so thus we have seen that this E is an equivalence containing R. ये हमने देखा. It is symmetric, it is reflexive, it is also transitive. So thus E is an equivalence. Thus E is an equivalence. Equivalence containing R. Containing R. E is an equivalence containing R. अपना कैमरा ऑन करिए सब लोग. 39, 51, 39. So this E is an equivalence containing R. हमें प्रूव क्या करना है? It is the smallest equivalence containing R. Now we take any equivalence which contains R and we show that E is contained in that relation. Okay, इस पेज को मैं इरेज करूं?
Yes, sir.
Now let it is an equivalence relation containing R. Okay. तो एक चीज हमें एक्चुअली प्रूव करना था, E इज आल्सो सिमेट्रिक है. तो हमने बताया था E इसके बराबर है, E is equal to R union R inverse union IX. अगर इतना होता then it's trivial, it's symmetric, but it's power infinity. वो आप चेक करना. Symmetric property is power. ये रिलेशन तो है खुद R union R inverse union IX, ये है symmetric, but it's power infinity. वो आपको चेक करना है, वो symmetric है. तो उसको आप प्लीज देख लेना. पावर अगर आपको देखना है कि ये S आपका सिमेट्रिक है, आपको चेक करना है क्या S पावर इन्फिनिटी भी सिमेट्रिक है, ये आपको देखना है. यहाँ पर R यूनियन R इनवर्स यूनियन IX ये सिमेट्रिक है बिकॉज इट कंटेन्स R एज वेल एज R इनवर्स. बट यू हैव टू चेक वेदर दिस S पावर इन्फिनिटी is reflexive or not. But I think that's again not trivial because S power infinity, that R union R inverse union Ix power infinity, it contains R union R inverse, but not we have to choose element pair in X actually power infinity. हमें power infinity हमें ये करना, अगर XY power infinity में है, R union R inverse union Ix power infinity में है, तो अगर without infinity होता then it was trivial ना, XY अगर इसमें तो YX भी होता, but it's power infinity. You have to show that this thing, this should imply YX also belongs to R union R inverse union Ix power infinity. That's your E relation है. तो ये सिमेट्रिक प्रॉपर्टी आप इसकी चेक कीजिए, मैंने चेक नहीं किया, इसको आप चेक करना इस प्रॉपर्टी को. This E is also symmetric. So now let's take any equivalence containing R. So now let tau be any equivalence containing R. We show that this E is contained in tau. ये हम प्रूव करेंगे. It is contained in tau. Containing R. Since R is subset of tau, so this implies its inverse is also subset of tau, because tau is symmetric. Because tau is symmetric. Also, the identity relation Ix is subset of tau, because tau is reflexive. Okay, because tau is reflexive. So therefore R union R inverse union Ix is contained in tau. So this is a relation which is contained in tau, but its power infinity is the smallest equivalence containing R union R inverse union Ix, and tau is also transitive. Therefore tau is a transitive relation. Thus tau actually equivalence है, therefore tau is transitive. Actually it's equivalence. Okay, आप यहाँ पर लिख सकते, it is equivalence. So equivalence relation is always transitive. Therefore tau is transitive containing R union R inverse union Ix. But we know that S power infinity is the smallest transitive containing S. So that means this relation R union R, या अगर आपका S होगा, so this tau is a transitive containing this S, containing the relation S, where S is equal to R union R inverse union Ix. But S power infinity is the smallest transitive containing R union containing S, where S is R union R inverse union Ix. So therefore this power infinity is also subset of tau, because power infinity is the smallest transitive relation containing this that union. So this implies R union R inverse union Ix power infinity is also subset of tau. So which is E actually, E is subset of tau. So hence E is the smallest equivalence, hence E is the smallest equivalence containing R. So therefore E is actually RE, because RE is the smallest by definition. E is equal to R power E. That is R power E is equal to E which is equal to R union R inverse union Ix power infinity. So now we'll do the next theorem. If R is a relation on a set X, if R is a relation on a set X, and this RE, it is the smallest equivalence, is the smallest equivalence containing R. Then the pair XY belongs to RE if and only if X equal to Y, or for some n in N, or for some n belongs to N, there is a sequence of transitions. There is a sequence of transitions. There is a sequence of transitions like this, which starts with, say, Z1, starts with X, that's called Z1, and there is a transition Z1 to Z2, then a transition Z2 to Z3, and you continue these, then we have this transition where this Zn is equal to Y. There is a sequence of transitions like this. What's this transition means? In which for each I belongs to the set 1 to n minus 1, either Zi, the pair Zi plus 1 is contained in R, or Zi plus 1 contained in R inverse. So transition का मतलब ये Z1 to Z2 transition means the pair Z1 Z2 belongs to R or its converse or inverse. इसी तरह से Z2 Z3 का मतलब ये है, इसका मतलब ये है कि जो pair है Z2 Z3 it belongs to R or it belongs to R inverse, and so on and so forth. So this is the theorem. So one way it's trivial, if X equal to Y or there is a sequence of transitions like this, then X and Y, the pair XY belongs to RE. That's trivial. तो इस ट्रांजिशन का नाम आप 1 रख दीजिए, क्योंकि हम ये बार बार नहीं लिखेंगे ये ट्रांजिशन के. नेम इट 1, दिस ट्रांजिशन, दैट द सीक्वेंस ऑफ ट्रांजिशंस है, इसका नाम 1 रख दीजिए आप. इसका नाम आप 1 रख दीजिए इस ट्रांजिशन से।